relations and functions. First comes the Cartesian product of sets. Set A having A1 and A2 and set B is having B1, B2, B3. The product will result in 6 ordered pairs, which is A1, B1, A1, B2, likewise up to A2, B3. Why it is called as ordered pair? Because order is important and A1, B2 is not equal to B2, A1. The simplest way to remember is whenever there is a product of such sets, the first set becomes the x-axis and the second set occupies the y-axis as shown here. Here A becomes x-axis and B becomes y-axis. So A1, B2, the location will be here. Now B has become the x-axis and A has become the y-axis. Now we will see B2, A1. Can you see here? This location is completely different from this location. That's why A1, B2 is not equal to B2, A1. Two ordered pairs are equal only if both first and second elements are also equal. There is an ordered pair A comma B and C comma D. They are equal only if A is also equal to C and B is also equal to D. Similarly, if set A is having P number of elements and set B is having Q number of elements, then the product A into B will result in P into Q number of elements. If both A and B are non-empty set and if any one of them is infinite set, then A into B will also be infinite. There is another thing called ordered triplet, which is A into A into A equal to, it will always result in A comma B comma C in a ordered manner. See, all the sets are A. That means it can be jumbled in any place you want. You can put the first A into second some other place and any other place. It will always result in the same ordered triplet only. Then comes the relations. If there are two sets, P is equal to ABC and Q is equal to the name of the students, Ali, Banu, Binay, Chandra, Divya, then P into Q will have 15 ordered pairs since it is having 3 elements and Q is having 5 elements. So set P into Q will have 15 ordered pairs, which is A comma Ali, A comma Banu, A comma Bijay, likewise for B and C. We can attain a subset of P into Q by introducing a relation R between X and Y of each ordered pair where X belongs to P. X is nothing but they are saying whatever the A, B, C has in a simple word as X, and Y is nothing but the Ali, Banu, Bijay, Chandra, Divya as Y. Let's say a relation, we'll say a relation where X is the first letter of Y. The visual representation can be as shown in the arrow diagram below. X is the first letter of Y. A forms Ali, B forms Banu and Binay, C forms Chandra, Divya is left out. In a subset derived by relation R, the second element Y is called the image of the first element X. The set of all first elements of the ordered pair in a relation is called domain of the relation R. The set of all second elements of the ordered pair in a relation from A to B is called a range of the relation R. The whole set B is called codomain of the relation R, and the range is a subset of codomain. Then comes the function. Function is a special type of relation. It can be visualized as a rule. It can produce new elements out of the given elements. A relation F from set A to B is called as function if every element of set A has only one image in set B. It should not result in 2 or 3 images. It should give unique answer. That's what it means. It should have only one image in set B. And f of A equal to B, where B is the image of A under F and A is the pre-image of B under F. If R, that is real numbers, or its subset becomes the range of a function, then it is called as a real valued function. Additionally, if the domain is also of either real numbers or the subset of real numbers, then such a function is called as real function. We will see some commonly used functions. The first one is identity function, where f of x is equal to x and all the x belongs to real numbers. It is just a straight line passing through the origin. There are many number of functions are there. There are some commonly used functions are listed here, so that you can easily recognize the pattern when such functions appear and can apply the relevant formulas. The second one is the constant function. The one classic example you might have studied in your previous classes is y equation of a straight line, which is y equal to mx plus c, where m is the slope. If m becomes 0, then y is simply equal to c. That is what it's shown here. F of x is equal to 3. Whatever is on the left side of the equation, that usually gets plotted on x-axis. On the right side becomes the y-axis. And this is not only for constant, it is for all the functions. For visualization of the function, the f of whatever is the x, y, a, b, c, whatever, that becomes the x-axis, and whatever is the answer, that becomes the y-axis. Then comes the polynomial function. F of x is equal to a0 plus a1 x plus a2 x square up to an xn, where n is a non-negative integer and all the a's belong to real numbers. The visual representation of f of x is equal to x square is shown here. Whatever is f of x, that becomes the x-axis and the answer becomes the y-axis. This visualization is for rational function, where f of x is equal to 1 by x. Then comes the modulus function, where whatever is the f of x, the value, it will the sign of the x will get removed. It will become positive. It can be minus or plus, whatever it is. Only the values are retained, and this is how the visual representation is. Then comes the signum function. If x is equal to 0, then y will be 0. If it is greater than 0, then whatever is the value, y will be equal to plus 1. If x is less than 0, whatever is the value, then y will become minus 1. Then comes the greatest integer function. F of x is equal to x represented in a box brackets. Then is the algebra of real functions. Addition. If f of x to r and g of x to r, then function f plus g of x to r is simply f of x plus g of x. It is a simple addition only, nothing much like in a Boolean operation, something like that. Just a simple addition. The same is for subtraction. F minus g of x is equal to f of x minus g of x. Again, multiplications by scalar. Let a is a scalar, a being a real number, then the product a times f of x to r is defined by simply the scalar multiplied by the function f of x. Multiplication by two real functions is, again, let's say f of x to r and g of x to r, then the multiplication of f into g of x equal to f of x into g of x. It's just straightforward, nothing complex here. Then quotient of two real functions, f by g of x equal to f of x by g of x, provided g of x is not equal to 0. Just a simple division to find a quotient.